with our plant maintenance. So, to handle with the maintenance of the plant, we will start studying why it is so important to do properly our plant maintenance during the operation. Then, we will see which are the main components to maintain and the types of maintenance that can be done. And we will end this webinar with the stock management and the spare parts management in our PV facility. So, let's start with the first chapter, the importance of the plant maintenance during the operation. Here, you can find a brief introduction about the different types of maintenance that may be useful to know before starting with this session. We can distinguish among three types of maintenance: the predictive maintenance, the preventive maintenance, and the corrective maintenance. The predictive maintenance is a type of maintenance which is only used in solar plants with sun tracking systems, and which tries to predict the plant performance in the future in order to prevent possible malfunctions. An example could be that if a piece of a sun tracker is supposed to live during 10 years, we can substitute it the 9th year in order to avoid a serious failure in the future. The preventive maintenance tries to set a periodical task to guarantee the plant lifetime, avoiding incidences to happen. And then, the corrective maintenance handles with the incidents once that they have already happened. When designing our maintenance protocols, we have to know that we must consider the enforced legislation for each country. In some countries, the government defines the type of compulsory maintenances or control tasks to be done in a solar plant. So, if this is the case, we must integrate these policies in the plant maintenance program. By the other side, if there is no legislation for PV facilities, our own criteria must be implemented in order to program our maintenance tasks. Once we have already considered the enforced legislation, there are many options to define how the plant maintenance should be done. The key points to analyze should be: first, the maintenance responsible, which could be the promoter, the installer, or a specialized company. Then, we have to analyze the plant staff, where we can decide if we want continuous present or intermittent presence, or even if we want to have a staff who moves to our solar plant only if the incident happens. The control and surveillance system, although they have already been studied in a different webinar, are really important to be considered during the design of our maintenance policy. So, we will do a small review in this webinar. About the control and supervision system, as we saw in the webinar 3, we can decide between an advanced monitoring system or a simple monitoring system, or we can just have a monitoring system for the inverter. And for the surveillance system, we can have our own personnel in the plant, a remote surveillance system, or the combination of both. If we remember, our recommendation... Sorry, I was reading the chat. I think, do you hear me properly?
I can hear you properly. I think it's probably a problem linked to internet connection or the sound settings. So for all our audience, please set your connection speed to LAN if you are a broadband or modem otherwise. You can find this setting on the top left corner and hit menu that can my settings. Thank you very much. You can go ahead, Javier.
Okay, thank you, Fernando. So, well, I was saying that if you remember from the last webinar session, our recommendation was having both personnel in the plant and a remote surveillance system. A good practice for choosing an accurate maintenance policy could be answering to the questions in this slide. Who, how, and with which tools? The answer will probably depend on our plant size. For example, here you have a table showing the recommended options for different sizes of ground facilities depending if we are using sun trackers or not. As you can see, if we are using sun trackers, obviously we will need more maintenance than if we don't use them. So, for example, for a solar plant between 1 to 2 megawatts, we will have one person full-time and an advanced monitoring system if we are using sun trackers, and we will only require one person half-time if we are not using sun trackers. So, we have already gone through the main aspects to consider for our plant maintenance. But during the next slides, we will study deeply those which have a higher influence in the cost of our maintenance policy. The first will be the staff in the plant. Our main aim must be to optimize the response time to every incident and to reduce the number of incidences by a well-managed preventive maintenance. In order to do this, the maintenance responsible must be independent and very well trained in both a functional and a documentary level. In a functional level, he should have enough skills to manage the maintenance of one or several plants by himself. And in a documentary level, he might have skills to create and update the records of maintenance and the records of incidents. The cost of this staff will obviously depend on the number of persons and the capabilities. Talking about the spare part stock management, a bad management of supplies can mean complete days of stop of an installation. So, it is essential to have an updated list of all the spare parts in the plant and to assure there is enough quantity. As we have already said, the two aspects that we can find in this slide have already been studied during the webinar 3. But just to remember the main points, we will say that for the surveillance system, the inconvenience caused due to thefts can mean a high cost for our plant. So, even if we have an assurance that pays for the stolen elements, we should check that the insurance covers also the loss in production and considerable labor works. For the monitoring system, we must know that a well-implemented supervision may have a great influence in the corrective maintenance, as it helps us to detect any possible incident before it causes a serious breakdown in our solar plant. To end with the operations and maintenance cost, we will talk about the insurance and the land renting contract, the supplies and the taxes. About the insurance, the main issues to cover are the effects of meteorological conditions. We will check later which are the main risks to find in our solar plant. About the land renting contract, we can only recommend to clearly specify with the contractor the surface, the terms, and the cost of our landscape. Finally, we have to consider the supplies, like for example, the water, the light, and the internet, and all the taxes that we have to pay, but as they depend on each country, we will not study them in this webinar session. To end with this chapter, we can say that from our experience, the annual maintenance and the operation cost referred to the plant cost will be around a 1% for a solar plant that doesn't have sun trackers, about a 1.3% for a solar plant that includes sun trackers, and about a 0.7% for solar plants in over solar roofs. As you can read in the box at the bottom of this webinar, this percentage has been calculated not taking into account the cost of physical surveillance, and we have considered a cost per hour of a guard from an outsourcing company of around €1 per hour. That is the cost that we should find in Spain for one of these companies. So, now we will see which are the main components to maintain in our solar PV facility. The first component to maintain will be the PV module, as it is the most massive element within the facility. Normally, the manufacturers guarantee that with a minimal performance during 25 years. The panel won't have any manufacturing defect during the first 3 to 5 years, so this element should never be repaired, as if we analyze the panel and we find any defect, normally it must be replaced by the manufacturer. Now we will study how to do this analysis. We have to check if the panel has any manufacturing defects when we receive it, and then we have to check periodically if it has any production defect. The manufacturing defects should be detected visually when receiving the panels, and also we have to check them periodically. We have to consider checking the defective frames. If the panels have any yellowing effect, that means that the panel becomes yellow in some areas in the panel, if there are any defective connection boxes, or if we get any glass broken. In order to detect production defects, we have to know that they are hard to be detected, because sometimes other components can be involved. So, it is important to isolate the defect and to confirm that it has been produced just because of the modules, and that it happens in the modules. First, we have to detect which is the array that has the issue. So, in small facilities, we can do a manual testing for each array, but normally, within large facilities, the monitoring system has to control each array separately, and if we want to detect this kind of defects, the monitoring system should notify which array is failing. Once that we have detected which array is failing, we have to detect the defective panels within this array. We can do it by testing both the voltage and the current for each panel. Or we can do an inspection with a thermographic camera, as we said during one of the last webinars. if the voltage is lower than usual, or if we detect any hot spot, that panel normally will have a defect and should be replaced. As we have said, normally the manufacturer has to be in charge of this replacement. The inverter is one of the most important elements of the plant to be maintained, because as we have seen in the previous webinars, it can be considered as the heart of our PV facility. Our strategy to maintain the inverter may vary depending on the type of inverter and its size. For small inverters, we should have a number of inverters in stock in the plant, so that when a malfunction is detected because of an incident, that we can remember that normally our monitoring system should notify us this kind of malfunctions, the inverter must be replaced by one of the ones that we have in stock, in order not to lose production and to save as much time, so as much money as possible. And then that piece or that inverter which is failing must be sent to the factory for its reparation. With this kind of policy, we can avoid production losses, as if we have a stock, we do not depend on third parties, and we can replace the defective element really fast within our own. If we are using bigger inverters, we can find two options: getting a manufacturer maintenance or doing the manufacturer by our own. We can contract the manufacturer maintenance so that we don't need any qualified personnel in our plant. The main disadvantage for this solution is that we depend on the manufacturer if any incident happens. So, if this is the case, it is important to know that if we send the inverter to be repaired in the factory, it may take more than a week to be repaired. So, it is essential to add a clause for indemnity in case of production losses in the contract. Normally, if the reparation takes more than a certain period, which should be less than 48 hours, the manufacturer must be responsible for the losses of the production losses in our solar plant. The second option would be doing the maintenance by our own company, so that the reparation can be done really faster. But then we will need qualified personnel in the plant. This personnel must be trained by the inverter manufacturer. If this is the case, it is important to have spare parts in stock, even if they are expensive. We have to remember that the main aim for this option is not depending on a third party. Normally, the maintenance by our own will only be profitable in large facilities. So, for small facilities, we recommend to contract the manufacturer's maintenance. Anyway, it is important to know that in any case, if we want to guarantee a fast reparation, we must have spare parts in our solar plant. The sun tracker is an element which needs a lot of maintenance, as it is composed of mechanical and electrical devices which are controlled by a software. For its mechanical devices, the preventive maintenance is really important, as if an incident happens, the cost to repair these incidents once that it has already happened, so that it has already produced damages to the inverter, can be very high. The main tasks to be done periodically are the motor lubrication and the sensor state supervision. By the other side, the software must always be updated to the last version in order to reduce the cost and the time. Then we can consider the possibility to remotely update this software. We can also get the option to outsource the maintenance of sound trackers or to employ qualified personnel to do it ourselves. Normally, as in the case of the inverters, this will depend on the size of our solar plant. For a larger amount of units, it might be interesting outsourcing the maintenance of our sound trackers. Now, during the following slides, we will see the maintenance to be done for the control cabinets, the protections, and the cables. For the control cabinets, the preventive maintenance is very important. We have to periodically check the state of the control cabinets by a visual inspection, and we have to check their state after bad weather conditions. For example, after a hard storm, maybe some water could have gone inside the cabinet, and if the control cabinet has lost its capabilities, it must be replaced as soon as possible. Anyway, we have to know that normally these kind of elements don't usually fail. The protections, the spare parts stocks is very important. We should do a preventive maintenance and periodical test to those protections that can be tested. We also have to do periodical inspections to all the connections of our protection devices. If any defect is detected, the device must be immediately replaced. The most typical incidents that may happen in this kind of devices is a bad connection which can produce an electrical arc, and this may rise the temperature and cause the device breakdown. As we have said, because of these incidents, a part of our solar plant can stop, so it is very important to replace this element as fast as possible. We will see it later, but the spare parts stock will depend on the cost of these parts. So it is very important to have a lot of protection elements, not a lot, it is important to have protection elements just in case that one of them fails. For the cable, if our facility is without sound trackers, it will be enough if we check the connections between the different equipments, and if we check those parts where the cable cover can be damaged after the execution of the solar plant. But if we are using sound tracker systems, then it is important to check periodically the cable route and to test if there are any important mechanical tensions at any point. The last element to maintain will be the meter. The meters are solid devices which shouldn't normally fail. Once they are installed and the plant has been already commissioned, the electrical company will seal the meter in order to avoid them to be operated by us. Anyway, as they have a critical function in our solar plant, a preventive maintenance should be done. A good practice will be to check if the data being sent by the meter is logical, and if it is the same as the one that we can read in the display. Normally we can check this with the monitoring system that should have all the values that are read from the meters. If we detect an incident, we must contact the electrical company, because as we have already said, they usually seal the meter after being commissioned. So they will tell us the instructions to solve each type of incidents. Break.
Okay, great, Javier. Thank you very much for this presentation. So, to everybody, you are attending the fourth session of this training course. There is two remaining sessions, so 2 days. We have the fifth lesson about economic analysis of photovoltaic installations. So the expected generation, the applicable tariffs, and internal rate of returns. Okay, so this is for the fifth lesson, and for the sixth lesson will be about off-grid systems. So the required considerations for isolated photovoltaic facilities. We will consider developing this topic in a dedicated webinar series upcoming for 2011. Meanwhile, we will have a dedicated session on October the 6th. Very well, you can set your connection settings by using the meeting menu. Then you select the connection speed, so you will have the possibility to improve your sound quality and the connection quality. Well, together with this, I take advantage to announce that we are also organizing webinar series on concentrated solar power. So it's available, the information markets, which are Spain, US, India, Middle East and North Africa, South Africa, Australia, etc. We'll have also a session dedicated to solar desalination, especially using concentrated solar power technology, which is a promising technology. So still in the demonstration phase. I will have also in-depth sessions dedicated to solar resource determination, provided by Chris Gemar, an expert in this field. So if you're interested in these topics, you can join us. You will need a new registration for this course, which is different from this one. So do not hesitate to visit Leonardo Energy website. Okay, in the meanwhile, Javier, you can resume the presentation whenever it's suitable for you. Thank you very much.
Well, okay. Please tell me if I have any problems with the sound, but I think I have the same configuration that I had before. So we will continue this webinar with the types of maintenance. Though this chapter is called Types of Maintenance, during the next chapter, in fact, we will study how to implement the preventive maintenance in the different stages of a PV project. You can find all the types of maintenance and a short description of them in the first slide of this presentation, because finally we decided to give this small briefing at the beginning of this presentation in order for you to know the types of maintenance before starting with the plant maintenance. So, right now, as I have just said, we will talk about the preventive maintenance, which is the most important type of maintenance as it avoids the incidents to happen. So, it must be present in all the stages of our PV project, in the design, in the execution, and finally during the operation of our solar plant. So, even before this is important of the plant operation, the preventive maintenance must already be taken into account. During the plant design, during the component provisioning, during the component reception, when selecting the equipment and its guarantees, and when selecting our insurance contract. We cannot think about the plant maintenance as a man with his tools without a protocol. The preventive maintenance must be structured and must consider all the incidents that may happen in our solar plant. During the next slides, we will go through certain questions to guarantee that the solar project and its preventive maintenance is being well implemented during all the stages of our PV plant. We will do it as a checklist that you can use when facing a new project. So, we will start with the preventive maintenance during the plant design. We should answer to 10 questions that we are going to go through during the 3 next slides. First, we have to answer if the parameters of radiation and tilt of the modules has been well studied. Maybe if we have done an optimistic study, we could be expecting a performance of over the real capabilities of the plant. Second, we have to check if the shadowing study has been done properly, optimizing the balance between the losses for shadings versus the optimization of the plot. Notice that, in case of using sun trackers, this study will be determinant for our plant performance, and we have to develop a wind study in the zone in order to properly determine the sun tracker specs. Third, we have to ask ourselves if we have taken into account the salinity and humidity of the local atmosphere, because it can influence the structure and the screws that we have selected. Fourth, talking about the quality of the soil, we have to be sure that we have verified the absence of any materials that may attack the concrete and debilitate the fixation to the soil. Then, the fifth will be checking that all the equipments that are to be installed outdoor have the minimal protection level for outdoor condition. Normally, this protection level will be IP65. Sixth, we have to check that all the important components are protected by voltage dischargers. Seventh, those control cabinets or control rooms which contain various devices, we have to check that they do have an appropriate cooling system, especially for those which are containing the inverters or the transformers. Then we have to check that all the electrical cabinets have dimensions and sizes enough to dissipate all the heat that may be produced because of the devices inside them. And we have to check all these conditions, especially during the summer in the north hemisphere and during the winter in the south hemisphere. Ninth, we have to check that the section of the cables is adapted to avoid possible voltage drops. And the last one, the 10th, a good advice is to distribute the main elements in several isolated rooms in order to avoid losing the whole production in case of a fire or flood. We have to verify that we have tried doing it during the design stage. So, during the supply of components, we have to take special care for the modules and the inverters. As we have already said, those are the main elements in our solar plant and are the most expensive elements that we will have. For the modules, we have 3 questions. First, have the modules that we have selected been certified by a certified laboratory? Second, do they fulfill the standard which is applicable for the country where we are doing our solar facility? Normally in Europe it will be the standard EN 61.215. And third, we have to verify if they are class 2. Then, for the inverters, we have to answer only to 2 questions. First, we have to check that they have a reasonable European efficiency, which may be between 94 and 96%. As we have insisted during the last webinars, we have to check that we are verifying the European efficiency instead of the normal efficiency, as the European efficiency is the one that depends on the load that we have on our inverter. And second, we have to check if they have a suitable galvanic protection that should have at least a minimum thickness of 80 microns. If we do not have this kind of protection, we should have an equivalent treatment at least. In order to get the required guarantees for the devices of our facility, we will also have to check some points about the guarantees. Talking about the solar modules, as we have already said within this webinar, nearly all the manufacturers guarantee a degradation of less than 20% after 25 years. But what happens for manufacturing defects? The guarantee varies from 2 to 5 years. So, we have to check how many years does the manufacturer that we have selected guarantee for this type of defects. Also, some manufacturers guarantee a degradation of less than 10% after 10 years. So, this is better for the performance of our plant than just the simple guarantee of having a degradation of less than 20% after 25 years. We have to check with the manufacturer if he is offering this kind of guarantee also. It is important to know that the guarantees are particularly important in the thin film modules, because they normally can suffer a strong initial degradation, and some manufacturers don't offer a degradation guarantee. So be careful if you select these kind of modules to check with the manufacturer that the conditions of the guarantees fit with the performance of your solar plant. To end with the modules, it is important to know whether the manufacturer or the distributor is the one who offers us the guarantee. In the case that the distributor is offering us the guarantee, it is important to select a distributor who is installed in our country. But if he is not installed in our country, then we have to verify that he has the right to sell to our country and that all the chain of guarantees is guaranteed in the contract. We have to take into account that verbal guarantees are not enough, and it is really important to check that all the guarantees are well detailed in the contract that we sign with the manufacturer. For the inverters, we have to check that the guarantees can be extended to the maximum number of years at a reasonable cost. The most important services to get from the inverter manufacturer could be the replacement service within 24 to 48 hours and the hotline service in order to answer all the questions even within the weekends. During the component reception, 3 points could be enough. First, have we done a visual inspection of all the modules that we have received, or at least a sample of them? Second, have we done a classification of the modules by power that we can do it using the manufacturer flash list? And third, are all the components stored in the suitable conditions during the period of the assembly and execution of our PV facility? Have to know that this is also important and is to be applied for the storage of the spare parts and the stock management later during the operation of our solar plant. Here, we can find a list of the main issues that our insurance may cover. It is important to check that the insurance that we have contracted has a suitable coverage. Now we get to the preventive maintenance during the plant operation, which is the most important maintenance that we have to define and to structure. The key points are designing a good preventive maintenance program, doing a complete training for our plant staff, having a good incident detection system, so a good monitoring system and a good surveillance system, correctly managing our spare parts and stock in the plant, having a good meteorological station to get reliable weather predictions, and installing a secure physical and remote surveillance system. During the next slide, we will talk about each of these key points. We will start studying how to design a good preventive maintenance program. It is necessary to define the maintenance tasks and their periodicity. So, you can find an example on how to do that in the bottom part of this slide. It is important to define them in a table with the date of accomplishment for all the tasks in our maintenance program and logging a record of each task. So, for example, in the table you can find that a task to be done will be checking the cable's state. This task is to be done yearly, and here we can fix the date when it has to be done. Sometimes we can include notifications in the monitoring system, and we can have alarms that notifies us when we have to do these tasks in order to do them on time. So, in this slide we can find a list of the tasks that generally require preventive maintenance. The earthing system checking of all the elements of our PV facility, the retightening of all the electrical connections in the control cabinets, the checking of the voltage dischargers and the cable state, the checking of the module dirtiness and the hot spots in the modules, and the verification of the maintenance required by the electrical companies in the transformation center. Finally, if we have sun trackers in our solar plant, we have to check that their deviation according to the position of the sun is within a range. And we also have to lubricate all their components and to retighten their screws periodically. It's important to do a maintenance task follow-up for all the tasks in our maintenance program, with individual records for each of the tasks, classified depending on the affected device or component. For example, here in the bottom of this slide, we can find an example of the sun tracker tasks record. As you can see, we have to write down the date when each task has been developed, and we also have to write some observations, like, for example, if we have detected any malfunction, or if this task was to be done routinary or because of a punctual incident. Talking about the training of our staff, the main point will be employing a plant responsible with an important electrical formation and reasonable knowledge on solar power. If the plant is using sun trackers, then he must also have electromechanical formation. The training of personnel is very important if we have decided not to outsource the inverter's maintenance, and it is really important if we have decided to use sun trackers in our solar plant. For the meteorological predictions, we have to know that they are really important to be taken into account in plants which have sun trackers. This is because the wind may cause serious damages to the sun trackers. As we have already studied during the last webinar session, the sun tracker must have protections against the wind, being positioned horizontally when receiving a signal from the central anemometer. Even a more secure solution will be having each sun tracker with its own wind sensor, but this can do our solar plant much more expensive. So we have to consider having a good communication system and a good monitoring system that notifies all the sun trackers when they have to protect from the wind. And with this slide, we finish with the preventive maintenance during the plant operation. So, we have to establish an incident detection mechanism for every incident that may happen in our facility, considering both its probability to happen and the damages it will produce. A good example of incidents could be the detection of a fire in the transformation center, in the meter room, or in the control and supervision room. This is not very probable to happen, but if it happens, can produce a very hard damage. So, an incident detection mechanism must be installed for this kind of incidents. And we end this chapter with the grid breakdown detection. Certain issues which are normally coming from the electrical company may cause the plant disconnection from the grid. This is usually a fault from the electrical company, and they should compensate it, but sometimes the breakdown can be unnoticed for the electrical company or even ignored. And if they are not demonstrable, these breakdowns, they may not be recognized or compensated. So it is very important for us to detect these kind of failures as soon as they happen and notify the responsible person in our solar plant so that he can prevent the company that this kind of failure is happening. We insist that sometimes the electrical company can even ignore this kind of malfunctions, and they won't pay us any production losses if we don't notify them as soon as possible. Now we will end this session with a couple of slides about the spare parts and the stock management. So, for the spare parts management, it is very useful and very important to have a list of spare parts evaluating if each element is critical, the malfunction probability for each element or device, and the delivery time from our distributor or from our manufacturer, depending on who is offering us the guarantees. For example, here you can find a table for some of the devices within our PV facility. In the case of the inverter, as we can see in this table, it is a very critical element with a low probability to fail and a delivery time of about 1 week. Well, if we have signed the contract with the inverter manufacturer with a maintenance contract, then we can specify in this contract, as we have said before, that the delivery time in case of malfunction should be less than 48 hours. Here, in this last slide, we can see that normally we should have from 0.5% to a 2% of spare parts for each element or device in our solar plant. The real quantity may depend on its evaluation, the evaluation that we have seen in the previous slide, and it will depend, as we said when talking about the protections, in the price of each device. Anyway, a good recommendation that you can find in the previous slide could be having spare parts of expensive elements such as the inverter only if our PV facility is over 500 kilowatts. Here in the picture that you can find at the right part of the slide, you can see more or less the supply chain for spare parts, and with the importance that we give to the management and the importance of using a software to control the stock for large facilities, telling us the dates when the spare parts are being used and when they are being received in order to improve periodically these timelines. So, here we finish with this webinar session 4 about the plant maintenance. During the next webinar, we will talk about the plant profitability. If you want to contact with our company, you can find our mail address and contact information in our webpage www.generalia.es. So, thank you for attending to this webinar session and see you on the next webinar on Thursday. I don't know, Fernando, if we have any time for some of the questions, or, well, I give you the microphone.
Okay, thank you very much, Javier, for this presentation. Very well done. So, well, we can proceed with some questions. We can allocate 5 to 10 minutes to questions, and some of rest of questions that you sent will be treated in a written way. So we will provide a written answer in a few days. So Javier, I let you the controls to select the question you would like to send to the audience. In the meanwhile, I'm resizing the pods. Thank you. Meanwhile, message for our audience: you can remain connected. We will be treating some questions for about 10 minutes. Otherwise, you can also keep chatting. So I will enlarge the chat pod in order to allow you more space for chat. So, duration and well, Javier, floor is yours.
Okay, well, I have selected this question because I have already seen it in the last webinar also, one question similar to this one. So, the question would be, what type of effect can snow have on the energy output? So, well, obviously, if the panel gets covered by the snow, then we may expect no production from that panel because it is covered and no sun might get to the panel. But we have to know that normally all the facilities have a selected field to get the most irradiation from the sun. So normally the snow, if there is sun if it is a sunny day, then the snow might be melted really soon, and the production can even get higher because of the low temperatures. As we saw during webinar 2, I think the panel has losses because of the temperature. So if the weather conditions are colder, then we can expect having more energy produced in if it is a snowy area. But well, we have to consider that normally snowy areas have less sun, so we have to do the balance between these 2 points. Well, I have selected a new question from Bill Rumbley that he's asking what is the difference in maintenance between single axis and two axis sun trackers. Well, the main difference will be that in two axis sun trackers we have normally two motors and we also have two sensors. So as we have said during this webinar that the main maintenance tasks to be done for the sun trackers are the maintenance, the lubricating of the motors and the maintenance of the sensors, then we might guess that this kind of facilities are more risky, but normally we have to include this in our project profitability calculation and analysis, because the performance of this kind of solar facilities with two axis sun trackers is higher, but obviously the maintenance cost might also be higher. We have to do the balance depending on the increase of production that we expect because of these two axis sun trackers, and depending also in the risks that we want to take. Normally, in many countries in the world, lately, because of these risks and because of the new prices of the panels and of the solar modules, we can find that people are not getting the risk to install this kind of sun trackers, and they usually are using fixed facilities, fixed ground facilities. Well, Fernando, you tell me when I finish with the with this question and answer session. But by the time I have selected a new interesting question, because maybe it hasn't been clear in my exposition, which is in regard to insurance, do you consider material cost and profit loss? I think that this person is referring that whether the insurance includes the losing of production when an incident happens or not. So, as what I have said during this webinar is that we have to decide which kind of insurance we want to get, because there are some insurance that cover this kind of losses, and there are some insurance which don't cover them. So, depending on the risks that we are taking in our facility, for example, this kind of coverage might be more expensive or cheaper. For example, as I have just said, in a sun tracker facility, our risk to lose profit might be higher than in a ground fixed facility. So the insurance might be more expensive, but sometimes it can be profitable for us. It depends a little bit on the insurance negotiation that we can get, and also in the risks that we expect for our sun trackers or for our solar facility to fail.
So, Javier, in the meanwhile, you can proceed with one or two additional questions, then we will adjourn. Thank you.
So here we have another interesting question from a user that is asking if we can bypass a module in case of breakdown. Well, normally we cannot do this kind of solutions because we might decompensate the array of modules. So we might get a different voltage from that array than the voltage that we have in different arrays, as the modules are connected in series and parallels. So if we have less voltage in a module array, in a module series, than in others, we can even produce damages to the rest of the modules within that area of the installation, because that series will have less voltage than the rest of the series connected in parallel. So we have to be careful with this kind of solutions, because the best solution could be doing a bypass on the whole series in order to have the same voltage in all the area.
Okay, so Javier, we will go for the last question now. Thank you very much.
So I'm going to answer a question that I think that is related with the question about the snow, because there is a person that is asking what is the effect of the temperature in the energy output. Well, as we have said during the last webinars, but this is important to have it clear, the temperature has an influence in the panels that produce some losses in the panels. Normally, for crystalline modules, we can consider that the losses might be about a 4% for each 10 degrees over the 25 degrees that, well, of standard conditions. And for the thin film modules, these temperature losses, or this ratio, is lower, so we can expect just 2% of losses for each 10 degrees that the temperature is going higher. There are other elements that might be affected by the temperature, but the main elements are the modules. Then we have to consider that the inverters have to have a certain temperature range, and if we exceed this temperature range, we will have to install a cooling system, but well, that depends on our facility and is not normally considered for in general seminars like this one.
Great, Javier, thank you very much. So thank you everybody to attend this webinar, and see you in 2 days, this Thursday, for the 5th session. Thank you very much. See you soon. Javier, you have the floor.